Hello everyone and welcome to my channel. In this video we are going to perform fire analysis or forest fires, and so our area of interest will be somewhere in Aberdares. Aberdares is a forest that is found in Kenya, and it has had several incidences of forest fires. So we are going to explore the forest fires that happened in 2019 and 2022, and so we shall just look at the visualization and how what was some of the areas that were affected. So to get started, first of all, you need to open up Google Earth Engine. So you need to have created an account for Google Earth Engine, and you are ready to go. So the first things first, you need to export your shapefile, that is the shapefile for the Aberdares. So I have my shapefile here. I will share the link in the description so that you guys can also follow along. So here is the Aberdare. So I'm just going to click on the import to script, and this is going to import the script here as a table. So with that, we can now go ahead and also look for the Copernicus surface reflectance data. That is the data from the Copernicus, which is the data that we are going to use to analyze our region of interest. So here you need to click here and say SR S2 SR. So this is the Sentinel 2 underscore SR, so the surface reflectance. And here I'm just going to click on the first one. I just want to read through some description here. And so before that, I would like to change this back to light theme. So I'm just going to remove the dark theme here. I'm just going to click on my stylish, and then my styles, I will remove the dark theme to light theme so that you guys can read through. So the Sentinel scenes with processing baseline of 4 above their DN values. So here you can read through the description. You can see they say that Sentinel-2 is a wide swath, high-resolution multispectral imaging mission supporting Copernicus land monitoring studies, including the monitoring of vegetation, soil, and water cover, as well as observation of inland waterways and coastal areas. Yeah, so this is the data that we are going to use here. This is the Copernicus S2 SR harmonized. So you need to copy this snippet and then just close. So here you need to, so I'll now go back to my dark theme. So I'm just going to enable this one here. And then here you need to declare a variable called fire underscore data. Fire underscore data, like that, is equal to, and then I'm going to paste that image collection like that. Then the next thing is we need to filter out the bounds and also the date and some metadata. So here I'm going to say dot filter, so dot filter bounds, filter bounds, and this we are going to pass in our bounds. So here is the table, so I just copy that one and paste the table inside there. And also we are going to say dot filter date, so we are going to filter dates, and we want to begin from January. So January date 1st 2019, and then we are going up to, so we need to begin with the year, so 2019, my January dash date 1st, and then we need to end 2022 December, that is 31st. Then we need also to filter out, so I'll say filter meta data, like that, supposed to be data, metadata. And here we need to get the cloudy underscore pixel underscore percentage, like that. And this one is going to be less than, so you can say less underscore less than, and then we need to get the clouds less than 20%. Okay, so to do that, I think I forgot to mention something here. For you to know the cloud pixels written like this, you need to read through the description of our data set. So after that, I'm going to save the script. So here I will say AB fire, which is Aberdare fire. Then click on OK, and this is going to save the project. Okay, so we need to go ahead and now like select some bands for our NDVI. So we can also visualize the NDVI values. So to do that, I'm just going to say here NDVI, NDVI, and then I will say var NDVI underscore bands. So I'm going to select the bands and say fire data, dot select. Then you're going to select the bands. So for NDVI is always band the near infrared and red. So to do that, you need to go to you need to look at the bands first. So let me just remove the dark theme. So I'm going to disable that dark. Maybe you can just keep using the light theme, I don't know. So here I'm just going to click on the first one. Then let's look at the bands, and the bands here we have band 1 is aerosols, band 2 is blue, green, red, red edge 1, and near infrared. So we need to get the near infrared and the red, which is in the Sentinel data is band 4 red, and band 8 is the near infrared. Okay, so that is why we need to select band 8 here, band 8, and also we need to select band 4 like that. Okay, so the next thing is you can also print this out. To print, you just need to say print. You need to say print, and then you need to print your NDVI bands. So you can copy this one. Oops. You can say Control C, and then you paste it there. So if you save that and run, so to run, you need to just click on run, or you can Control Enter, and this is going to print out the bands for the bands that you selected. So if you can take a look here, if you just click on the first image and inside the bands, you see we only have two bands, that is band 8 and band 4. Okay, so you can just comment that because it is not adding any value. So I'm like to get the function to calculate the NDVI. So here I'm going to say function to calculate the NDVI like that. So I'll say var, and then I'll say calculate underscore NDVI is equal to a function. Then that function is going to take in an image. We shall need that image later on. So I'll say variable NDVI is equal to the image that we just passed in as the argument here, and we say dot normalized difference. So we need to get the normalized difference vegetation index like that, and then we need now to pass in the band. So I'll say band 8, and then I also need to pass in band 4. Okay, so if I do that, and then I can just say rename this to NDVI. So click on save. I'm just going to minimize this one here, and also we can also do that. So if I do that, then inside the function, I'm going to say how this function we are supposed to get all these things to the beginning of our line. Okay, so I don't want to have that indentation. Okay, so for that case here, you need to we need to also have another variable. So I'll say variable, and this variable is going to store our new image. So I'll say new underscore image. New image is equal to now the NDVI that we've just got from above. Then say dot add bands, and the bands are going to have the NDVI. Okay, Then after that, we need now to return the new image, new underscore image, like that. Okay, so after doing that, we are now we have already now calculated the NDVI, and so we can also get the bands to get the NDBI, which is the normalized difference band index. Okay, so we just keep this function here for NDVI. We shall use it later on, so let it just be there. And then down here I'm going to write another comment, and that says we need to select the bands. We need to select the bands for NDBI, like that. So to do that, it's almost the same process. We need to say var, and then we say NDBI bands. So NDBI underscore bands, like that, is equal to fire underscore data dot select, and then here we need to select the bands. So we need band 8 and band 12 for the band index. So that is near infrared, and let us just confirm band 12. What is band 12? So band 8, we are sure that this is near infrared, which is 10 meter resolution. Band 12 is the shortwave near infrared 2. Okay, so here I'm just going to say band 8, like that, and then we also need to select band 12. Okay, so after doing that, we need now to also calculate that. So I'll say here function to calculate the NDBI. Okay, then here I'll say var calculate underscore NDBI is equal to function, and this is supposed to be function, and this function is obviously going to take an image as an argument, and then inside here we also need to say var NDBI. So it's just like the same process, and say image dot normalized difference, and this is going to take in the bands as we have them here. So band 8, and also we need to get band 12, like that. Then we need to rename this to NDBI, like so. Then down here we also need to get the new image. So var new underscore new image is equal to NDBI dot add bands, and the bands, supposed to be bands, like that, and the bands is obviously going to be NDBI. Okay, then we need to return the new underscore image, like that. Okay, so we can also put a semicolon there. So click on save, and the next thing is that we need to now visualize both the NDBI and also the NDVI. Okay, so I'm going to create the visualization parameters here for the NDVI. So I'll say visualize NDBI, and so I'm going to say variable var NDBI params is equal to this object, and so we need to get the minimum value from -1 to the max value, to the maximum value as 1. Then we also need to have the palette. So the palette is going to be a list of colors. So I'll need to say red, also to have dark green, and also like to have the yellow color, and also have to get the green color, like that. And so after doing that, the next thing is now to map through all bands in the image for the NDVI and NDBI. So to do that here, just to say map through the bands for NDBI and NDVI, like that. So down here you need to say var NDVI underscore bands 2, because we already have the band, so we need to differentiate this, and this is going to be NDVI underscore bands. So we need to get the bands that we had, and then we say map, and then we need to pass in our function that is calculating the NDVI, since remember we're only working with one image, and we need to get to have all the images, since we want to get the image collection have an applied function for the NDVI instead of just having a single image. So that's why we are doing NDVI bands.map. So we need to map through the NDVI, and so if we do that, we shall have our NDVI bands 2, and so we also need to have the NDBI bands 2, and so we need to say var NDBI underscore bands 2 is equal to NDBI underscore bands dot map, and this we need to map through the NDBI like that. Okay, so after we've done that, now we can come here and say we can say var NDVI images is equal to now NDVI underscore bands 2 dot now select, and we're going to select the bands, that is the NDVI that we have, so NDVI. So remember what we did up here, after we got the NDBI, so let's check out the NDVI. So NDVI, we are creating a new image collection which has this band called NDVI. So after calculating the NDVI itself, which is a combination of the which is the summation of the near infrared minus red divided by near infrared plus red. I hope so because I'm just running this function here, but I think that is the basic function. So I don't know if plus comes first or the minus, but I hope you get the point. So that is how we normally do it in either QGIS or ArcGIS. So we need to add and then minus. So after we've gotten the NDVI, we rename that band as NDVI. So it's like a combination of this after calculation. So we got the final result as NDVI, the band. So that is the band that we are selecting here. Okay, so that we have our image getting all the NDVI values being applied. Okay, so then we also need to say var NDBI images is equal to NDBI underscore bands 2 dot select, and then we need to get the NDBI like that. So now we have the images for both NDVI and NDBI. The next thing is that we need now to calculate. We need to calculate the indices. So after getting the indices, we now get the difference for all the image collections, and then we add to the map to get the band areas. Okay, so to do that here, I'm just going to say calculate. Here I'll say calculate NDBI and NDVI for an image like that. So down here I will say var calculate indices, calculate indices is equal to a function, and this function is going to take an image as usual, and then inside this we need to say var NDVI NDBI is equal to image dot normalized difference, and inside we need to pass in the bands, so the list of bands. So as usual we have band 12, we have band 12, which is the shortwave near infrared, and we need to get band 8 like that, and then we shall say rename. We're going to rename this to NDBI, okay, and also we need to say var NDVI is equal to image dot normalized, this is supposed to be normalized difference, and then we pass in the bands for NDVI, which is band 8, the near infrared, like so, and also band 4 for red. Then we say dot rename, and now we are going to rename this to NDVI, okay. Then we need to say return. This is supposed to be return. We are going to return NDBI dot subtract NDVI. So that's what we are going to return. After we return that, we get the band index, okay. After we do that, this one needs to have the semicolon there. So the next thing is that we need to map over the image collection and calculate the difference. So to do that, since we have now our image, which is the calculated indices, we need to map through the image collection, since this is just a single image that we are doing. So to do that, you need to say var difference collection. So difference collection is equal to fire underscore data dot map, and we are going to map through the calculated indices. So just say Control-C that, and then paste it inside there. Okay, so after you've done that, you can also say print. You can also print and visualize this, and then you say difference collection. I don't think if we need to print that. We don't need to print that. Let's go ahead and visualize the first image of the difference collection. So here you can create a comment and say visualize the first image of the difference collection like that. So here I'll say var difference params is equal to an object that has the minimum value of -1 and the max value, which ranges from -1 to 1 as maximum, and the palette, we can have the color palette, which is going to be a list of bands. We can say red, white, we can say red, white, and also we can have blue. We can have blue like that. So we can have blue like that, and then down here we need now to get everything added to the map. So since we have done almost everything right, so here you just need to say add to map. So down here, first thing is that we need to center to our object. So you need to say map.center object. So this one helps you to center to your region of interest. So I'm going to center my region of interest, which is the table. I didn't rename this, but you can rename this to whatever the name of your region of interest is. So for me, I'll just keep it as simple as table. Then here I'll just pass in the zoom level. Then I'll say map.add layer, map.add layer, add layer, and we're going to add the NDVI images. So NDVI images, which we have up here. So we're going to add both this and this. Okay, so NDVI images, and then we need to just pick the median value. So I'll say median value, and then I'll say dot clip. So we're clipping this to our region of interest, which is the table. So after we do that, then we need to get these params, the NDVI params that we just passed in up here. Do we have the NDVI parameters? We don't have it yet, but we can just say pass in an empty visualization there. Then the name, of course, it is going to be NDVI. So I'm just going to duplicate this, and then here is going to be NDBI images.median, and then you are still going to clip to the table. And then here, since we have the parameters, we can just pass in these NDBI params. So Control C, that one, and then we can just pass it here, Control S, and so we change the name to NDBI, like so. So ensure to put a semicolon at the end. Okay, so let us save this and then run. Let's see if everything is okay. So click on run, and this is going to add to the map. Okay, so let's just wait and see. So it is here. So you have the NDBI and NDVI. Then you can also go ahead and add now the difference collection. So here I'm going to say map dot add layer, dot add layer, and here we need to add the difference collection. So just copy this one up here, the difference collection, Control C, that one, and then paste it here. So Control V, dot median value, then we say dot clip, clip to our region of interest, which is table, and then we also need to pass in the difference params, the ones that we just declared up here. So I'm going to paste them there as my visualization parameters, and then I need to get the name. So I'll say something like NDBI minus NDVI. Okay, Control S, and so to visualize this, you can see here that we have our NDVI. So this is our NDVI, and this one is our NDBI. So for NDVI, you can click on the, let's say, this icon here, the settings, and then you can see we have the band as NDVI, which is already selected. You can choose from gamma to palette. So here you can choose your own visualization palette. I'm just going to click on that color, click on apply. I need to click on this. So this one is supposed to go with this one, and then the second one, we need to go to 3. What is happening? Okay, so we need to add the color. So I click on this, click on that one, click on OK, click again. Let's choose maybe the yellow one. Click OK, then click again. Let's choose some greenish color. Click on Okay, it is hiding behind our small window here. Then I can just add some I don't know if blue will appear. Let's try this one here. Okay, so stretch this to something like 100% and then just apply. So click on apply and then close. Yeah, so we can see here, I think this kind of green, this kind of bluish color is not appearing so good. So we can change this one to some light green like that one. Click OK. Apply. Stretch to 100% and then you just click on apply. So apply and then close. Yeah. So you can see that we have the NDVI, and the NDVI shows that around this area here, the value for NDVI is quite low. So the value here is quite low. So perhaps this is the area that was affected by fire. We still don't know. But if we put the NDBI, you can see that actually reflects that these areas were quite affected by the fire because the values are low. Okay, but before that we need to set the threshold for the value. So if we can just give it a value like 0.1, and if that value goes above 0.1, then it means that area was affected by fire. Okay, so down here I will say we need to iterate through the collection and calculate the statistics. So here I can say calculate the statistics like that. And so first I'll need to set the threshold. So I'll say threshold value is equal to 0.1. So if it goes above 0.1, then it means that place is affected by fire. Okay, so after doing that, we need now to create a binary mask for burned areas using that threshold that we have. So here you can say variable burned areas is equal to, we need to get the difference collection like that, and then we need to say dot map. So we need to iterate through the collection, the difference, and then we pass in a function. On this function takes an image like that, and then we can say var burned mask is equal to the image dot greater than the threshold value. So if it is above the threshold value, it means that area is affected by fire. So that one becomes our burned area. So I'll pass in the threshold value like this, which is 0.1. So I say get that value, and then I'm going to return the burned mask. Mask dot, I'm just going to rename this, and I will say this is the burned is burned. So the area is burned like that. Okay, so control save that one. So the next thing is that we need to visualize the burned areas on the map. So here you can say visualize the burned areas on the map, and to do that you need to say var burned mask is equal to burned areas, which is a variable that we have above, dot reduce. So we call ee dot reducer. So the reducer function here dot any non-zero value, like so. So after we've done that, we need to get the So we need to say var band params is equal to, and this one is going to take in the palette, so we can pass in the palette, and the palette is going to have a list of colors. So we can just say green is going to be the area that was not affected, and red will show us the area that is affected by fire. After that, then we need to say map.add layer, map.add layer, and then we need to add the band mask. So Control C, that one, add layer. Then we need to say .clip, and we are clipping this to the region of interest, so which is the table. After that, we need to pass in the visualization params, which is the band params. So just copy this, Control C, that one, and paste it there. After that, you're now going to say, to give it a name, a layer name that says band areas, like that. Okay. So after you've done that, just click on save and run your project. So I'm just going to click on save and then run. So this is the map.add layer is not a function. So here, map.add layer is not a function, supposed to be add layer with a lowercase a. So save and run. So we are going to add 3 or 4. Is it 3 or 4? We are going to add 4. So we're going to add 4. So the first one is the band areas. The next one is the difference between the NDBI and NDVI. And so we have the NDVI alone and NDBI alone. Okay, so this is going to take some few minutes. As it does that, we can also go ahead and calculate the areas of abadeas in meters, and also we can also calculate in kilometers. So you can do that, and then you can also export the image to your drive so that you can maybe share with your friends or do some further advanced visualization. Okay, so if I just take a look at this one, so this is our image. Let me just remove this. We need to get the band areas because that is what has the band mask. So it is still loading. Let's go ahead and calculate the areas in meters. So here I can say area in meters, like that. So here you need to say var abadea underscore area underscore square meters is equal to the table. So the table is the whole geometry, so dot geometry, and the geometry is going to have dot area. So we call the area function from our Google Earth Engine functions, and then we pass in the max error. So you can say maximum error is going to be equal to 1. So the error is 1 meter, and then you can print out the areas in square meters. So to do that, you can just say print, then you say abadeas, area in square meters, like that. Then you say is, so is what? Is this variable here. So you copy this one and then just paste it there, like that. Okay. Then you can also change this to square kilometers. So I'm just going to say, I can just copy this. Oops. You can just copy this one here. Control C, that one, and then paste it there. Then say this is area in square kilometers, like that. So you say square kilometers, and the area is going to be Abadea's area in square meters. So we don't need to get all this one here because this is returning the one in square meters. So we just copy the square meters because we already have that variable here, paste it there, and then say dot divide. So this is mathematics. You need to divide by 1 million because 1000 meters is equal to 1 kilometer. So if we have 1000 square, if we have a square kilometer, then it means we have 1000 by 1000 square meters. So we need to divide by 1 million. 1, 2, 3, 1, 2, 3. Okay. Then here we just need to change this area in square kilometers. And it's going to be area in square kilometers, like that. So control save, and then you need to click on save and run. So before that, you can see that now we have our mask, our burnt mask, which is which shows that this area was affected by fire. So we just did a random threshold. So we just called a random threshold like 0.1. So above 0.1, it means that that area is a burnt mask. And you can see here, if you try to compare this with our NDBI or NDVI, you will realize that this area was affected by fire. Okay, so if you save and then run your code, so this one says that unrecognized argument maximum function geometry error projection returns area. Okay, so let's see what could be the problem here. So okay, so I think the problem is the typo here. We need to have a lowercase m as the maximum error, and then so you need to click on run. It says Abadea's square kilometer is not defined. Yes, it is not defined. So square kilometers, I think this one is a lowercase k, like that. So click on run, and now this is going to produce the area in square meters and also the area in square kilometers. But since we are not interested in that, we just want to see the areas that were affected by fire. So if you take a look at this, we are interested in especially in this area. So just remove this and this. So this area is the one that was affected so much by the fire that took place during that period that we have just specified, that is 2019 to 2022. And if you just compare this to our NDVI, so the NDVI is supposed to, let's take a look at the NDBI. What about the difference? So the difference is also not clear, but you can see here. So if you want to get the NDVI as we did previously, you need to go to the settings icon and then try to define your own visualization parameters. So go to palette, click on this one, click on the area, on the red one here, click that. Another one is let's get the yellow one, click OK, click on this green, let's say dark green, like that. Also let's get some light green, click OK, and then you need to stretch to 100% for clear pixel visualization. And then you need to click on apply, and you can also import that and then close. Okay, so now we can toggle around these areas, or these layers, I mean. So this is the NDVI that we have. If you check around, you can see that this area was this area has a very low vegetation index. So if it has low vegetation index, we can visualize that, we can correlate that with the burnt areas, and you can see that if it has a low vegetation index, it means perhaps that was also one of the areas that was affected by fire during that period of time. So time also here is a factor, and these areas, it looks like they are affected. If I just remove the NDVI and try to visualize the burned areas, you can see that we have actually a lot of areas that were affected, but they are quite small. So the mask is quite small, so it's not so clear. But you can see that around this border between these two counties is where the fire actually occurred, and it was, we can say that the severity here was very high compared to other areas of the forest. Yeah, so this is it. Thank you for watching. You can go ahead and also export this to your own drive. So to do that, you just need to export them to, you need to export as image. So you need to say export dot image dot to drive, export image to drive. And so what do we need to export here? We need to get the image, and the image is going to be the band mask. So the band mask, where is it? Just copy the band mask, this one here, the band mask, and you paste it there. And the next one is the scale. So scale is 30 meter resolution. Also get the file name. So how do you want it to be named in your folder? So file name prefix is going to be, you can call it NDBR, so difference normalized band ratio. Then down here you just need to get the region. So here you can say region, and the region is going to be the table and the max pixels, so maximum number of pixels that you want to import to export is 1 times 10 raised to power 10, something like that. So you need to say 1 exponential 10, like so. So after you do that, you control save, and then you click on run. So this is going to run and export your image to your drive. And so to check that, just go to the tasks at the far end here and click on run. So you export your image, you can give it a name, and then you just click on run. So depending on the heaviness of the image, it may take quite a longer period of time to download. For example, the one that I did before I recorded this video, it took 14 minutes. So yours can also take quite a longer period. So thank you for watching. This is it. If you have any questions or you like me to cover anything in the in Google Earth Engine, let me know in the comments section. Otherwise, enjoy the rest of the day.